Welcome to our final video. This is to walk you through your questions. So again, keep in mind what we're doing for each question. With question number 3, what you are doing is the operation that's stated within the square brackets, and you're doing it to both sides. So let's go through what these will look like. These should be nice and simple, nice, easy, and banging it out. So 5 plus x, and then I've added my 1 because it's telling me to do that, equals 10 plus 1. So I end up with, when I simplify, x plus 6, or 6 plus x, equals 11. Done. Hopping on to C. Next, I am dividing by 4 on both sides. So 12 divided by 4 gives me 3 on that side. And then I have 8q divided by 4 gives me 2q. Next one, I am adding 5 to both sides, so 7 plus b plus 5 gives me 10 plus 5. So I end up with 12 plus b, giving me 15, because 10 plus 5. Next one, I'm adding 2 to both sides, so I have 2 plus 2 equals 5 plus a, and again I'm adding 2. So let's simplify. 2 plus 2 is 4, 5 plus 2 is 7, plus a. And what I'm going to do, just so you can see it a little bit better, the operation that's done is all highlighted in that colour. Okay, so you can actually see where everything has come from. And again, what you do to one side, you have to do the other side as well. Now we can move on to the next question. So next question, show that these pair of equations are equivalent by stating the operation used. So for these types of ones, again, what you're after is figure out how you've gotten from this one to this one, and you need to tell me how you got there. So figure it out, then tell me exactly how you got there. So tell me the process. How did you get there? So let's go from here to here. Let's see what's in common and go from there. So having a look, I've got 4x, that's in common, so I'm not doing anything to that. I have plus 2 here. I don't have it here, so how can I get rid of that? And I've got 10 over here. So having a look, the difference between the 8 and the 10 is actually 2. So if I minus 2 from 10, I can get 8. And if I minus 2 from this expression, I'll only get 4x. So that is my answer for this one. So my process for this is minus 2 from both sides. Let's have a look at the next one. So for letter C, again, let's have a look at what we got in common. I've got 20a and I've got 2a. We're close, but I can see that 20a is bigger than 2a. So if it's a bigger number out the front, I might need to actually divide. So just putting it out there, and I've got 10 to 1. The easiest thing to have a look at, how do I get from 10 to 1 if I'm dividing? Because I have a bigger number and I want to get it to a smaller number. So if I try dividing by, say, 10, and what I do to one side, I have to do the other. Let's see what that does. So 10 divided by 10 gives me 1, and 20a divided by 10 gives me 2a. Beautiful. So my process for this is I have divided by 10 to both sides. So divide by 10 to both sides. Okay, let's have a look at our next one. So next one, again, we're starting here. We want to get here. How do I get there? So let's have a look at what we have in common. So I have 18 and 6. Okay. They're both multiples of 6 or 3. And I also have 3x and x. Anytime you have a coefficient, so that's the number outside of your pronumeral, so your number outside of your letter that's attached to it, try and do something with that, and that will usually get you to where you need to be. So if I'm playing around with that, let's do divide by 3. So 18 divided by 3 does indeed give me 6, and 3x divided by 3 does actually give me x. Beautiful. So my process for this one was that I divided by 3 for both sides. Okay, last one for question number 4. Hope you're getting a little bit of understanding from this too. So again, let's look for what's easiest. First thing I see is I have a 4 outside of my brackets. And I can see here that 10 plus b, this is the same here. So that's just a big thing, big red flag, big red light, or waving flag, telling me I should get rid of this multiplied by 4 to make my life a lot easier. So let's do that. So to undo my multiply by 4, I have to divide by 4, and what I do to one side, I do the other. So those two will actually cancel out, and that'll give me just 10 plus b. And then 80 divided by 4 does indeed give me 20. So my process for this one, I have divided both sides. So I've divided both sides by 4. Beautiful. On to question number 5. So for each of the following equations, show the equivalent equation that is the result of doing these 2 steps. And I've been really nice, and when you're going through these, it's good to write a little note of what you're doing. So I always do this because it helps me too. So by adding, so we're finding what the result is when we add 4 and then multiply by 3 to both sides. So we do this step first, then we do this step next. So first thing I'm going to do is add 4 to both sides. So x plus 4 equals 5 plus 4. And if you can simplify along the way, make your life easier and do it. So I can do that already. So x plus 4 equals 9. So that was my first step. Now let's do the one where we're multiplying it by 3. And I have to do that for both, so I'm going to do that just in another color, just so you can see it. So I've got x plus 4 equals 9, but I am multiplying them both by 3. So I can now write out, I can keep the brackets for the moment, and 9 times 3 gives me 27. We are done with that one. On to the next. So again, I'll do the blue as the first step and your orange as your second step, which is what you've done. You have multiplied by 3. So you can see it easily. So first thing, write it out. Then I've added 4 to both sides. And I end up with minus 4 plus 4. Okay, you end up just with d. So I've got d equals, and I can simplify 2 plus 4 to give me 6. Now let's multiply both sides by 3. So I've got d equals 6, and I've multiplied both sides by 3. So I end up with 3d, and 6 times 3 is 18. Beautiful, looking good. Next one, again, remember we're adding 4 to both sides, so let's write it out first. And then we are going to simplify from there. So let's do this, shall we? So 3y is still the same. Minus 2 plus 4, I end up with plus 2. So I started off with essentially 4 apples, and you took away 2, so I only have 2 left. And 7 plus 4 gives me 11. Okay, now the second step, remember, I'm multiplying by 3, so let's just write out our equation first. So I've got 3y plus 2, and I am multiplying by 3, and I had 11, and again I need to multiply it by 3. So I can keep my brackets, keep it nice and neat, and then I can multiply this part here. So 11 times 3 gives me 33. Okay, we're nearly halfway there. Keep in mind, question 9 is an extension question. I'm not going to do just B and C but have a go if you're up to that, and I'll show you a little bit about how that one works too. So question number 7. For each of the following pairs of equations, okay, for each of these, show that they are equivalent by listing the 2 steps required. So I need to know how to get there, and there are 2 steps. So essentially what you've been told here is what you are going to write as instructions in this space here for this particular question. Okay, so let's have a look. How can I get from here to here? And again, I'm doing what I do to one side, I do to the other side. So first thing I notice, I've got my m here, and I have to get to 10m. So always have a look at the pronumeral when you're doing this particular type of question. So I know to get from there to there, I've actually had to multiply by 10. So let's do that to both sides. So if I multiply by 10, that's going to be my first step. So if I do m equals 2 and I multiply it by 10 on both sides, I end up with 10m equals 20. Okay, we're getting there, but I need to get to 17 and I need to get this minus 3 in there. So let's actually minus 3 now. So my next step is going to be minus 3. So 10m minus 3, and what I do to one side, I do the other. So 20 minus 3 does indeed give me 17. So I've ended up with my equation by doing these 2 steps. So I would write a statement that says that I have multiplied everything by 10 and then minused 3. Next one, again, remember I'm going from here to here, and I want to make sure that it works. So first thing I can see, as I did previously, have a look at your pronumeral. I've gotten from 3x to x. Okay, that's looking a little bit too hard, because if I have a look at my numbers now, it doesn't quite make as much sense as I would like. So let's have a go at getting rid of this 10. So if it's 10 on both sides, let's try minusing 10. So remember, we're after that kind of reverse operation. So let's try minusing 10 to start off with. So 10 minus 10, and then I've got 3x plus 10 minus 10. So 10 minus 10 does indeed give me 0. And then I've got 3x, because 10 plus 10 minus 10, they cancel each other out. So now I've got 0 equals 3x, but I have to get the 3x by itself. So the way that I can do that is to actually divide by 3. So if I've done that, I do my 0 divided by 3, which gives me 0. And then I've got 3x divided by 3, which the 2 numbers cancel each other out, so I end up just with x for this one. Boom, I am done. And again, what you would write is, this is the process: minusing 10 from both sides and then dividing it by 3. Next question. For each of the following equations, write an equivalent equation in one operation. So I need to show you for this one how I can make a smaller one by doing only one step. Okay, so I want to make this smaller by only doing one step. So I can look at the pronumeral, or I can look at the number that is being added or subtracted. So that's not going to be as neat if I try to divide by 10 on both sides. So let's instead try to minus that 3. So if I've done, sorry, I'm just going to make it a little bit nicer. So if I try minusing 3 as my step, so I've got 10x plus 3 minus 3 equals 10 minus 3, because again, I have added it on both sides. So I end up with 10x equals 10 minus 3 is 7. That's looking smaller. That's definitely a viable option. Alright, let's have a go at this next one. So, next one I've got here. I've got 5 on one side. I'm not going to do much with that. And I've got to divide on this side. So, easiest thing I can actually do would actually be to multiply. So let's have a go at doing that and see if we end up with something that is smaller. So I've got, if I try to multiply by 12, so x divided by 12, then multiply by 12 equals 5 times 12. So again, these two will cancel each other out, and I end up with x by itself. And 5 times 12 gives me 60. Okay, that's not looking too bad, but apparently we wanted it to be smaller. So that might be a bit hard, but I think that one's actually a correct answer. Next one. So sometimes two equations that look quite different can actually be equivalent, but you might have to go through multiple steps. So these two are actually equivalent, but we have multiple steps that we go through to make the first one look like the second one. So we need to fill in the gaps. So if I've minus 2, that's what I've done in this first step to both sides. The next thing, I'm divided by 3 to both sides. So 3x divided by 3 gives me x, and 12 divided by 3 gives me 4. Now I'm multiplying them by 10, so 10 times x is 10x, and 4 multiplied by 10 gives me 40. And then the next one I'm adding 1, and boom, I am done. Now this question B and C. So again, you are doing the exact same process. Start with one thing that you can see that you can change. The easiest one to start off with, I would say for this particular question, is to do any of your plussing or minusing first, okay? Then you might have to deal with some multiplication or division. So your first step will be to look at, so your first step will be to look at whether you can plus or minus something. Your second step, you would start to actually look if you can multiply or divide something, and then repeat that process again. Okay, good luck.